Hi, I'm Robert Bolaños. In this video, I will be measuring the negative resistance of a power supply. Okay, so what is negative resistance? It's kind of a unusual concept. So I'm gonna go ahead and explore and talk about it a little bit. Well, because of the negative feedback of the converter, the power supply converter is actually a constant power unit, meaning that your output power and your input power track to each other. Okay, and we're going to assume that we have 100% efficiency. So with that, assuming that you have 100% efficiency, then you can say that the input power will always be the same as your output power and vice versa. Okay. So another way of expressing power would be the voltage squared divided by the input or your resistance. So this equation, V input squared R input squared, is another way of expressing input power. And like so, we can express output power as V out squared divided by R out. Okay, so here we have the same equation. Okay, and if we solve for Rn, we end up with this equation. This is the equation that you want to use. So I'm going to put it in the box. Okay. And remember, this equation is assuming 100% efficiency. Okay. Okay. So another way of expressing resistance is voltage over current. So we can kind of hand wave and say that the input resistance is proportional, at least, to V in divided by I input. Okay, so now that I made that statement, then we can say that V in and V current input, they're going to be the same as V out and I out. Okay, this is again because this is a constant power. You can make that statement. So basically, if you vary your input voltage, okay, let's say you put a wiggle, and let's say the input voltage goes out up. If you have a good feedback system, your output voltage is going to be the same, and if your output voltage is the same, your current is going to be the same. Okay. Now, what about the input? Okay, and specifically, what about I input? What happens? Well, as you increase V in goes up, your I input is going to decrease, so you keep the same power. Okay. Excuse me. So because of that, you actually experience a negative delta at your input current. So if you have an input current, then you can say that you have a negative resistance. Okay. And this, you can think of it as a small signal Rn. Okay, so that's where the concept of negative resistance to the input of a power supply comes from. Okay. Okay, so here I'm using the same equation that I used up there, except that now I'm accounting for efficiency right here. This is because of the power losses. Okay, so this is going to be efficiency. Okay, I'm using the same equation, and now here is my data from my flyback. Here I have my input voltage, my efficiency, and these are my output voltages. Okay, and here are my loads. Okay, and when I calculate the resistance, I get 88 for the first output voltage, about 378 for the second out voltage, and then a little bit under 2K for the third. And then when you put them in parallel and solve them, we end up with 68.9. So this should be at least close, negative 60, let's say 69 ohms. This should be the negative resistance that my flyback should measure, at least close to it. Okay. So what equipment do I need? Okay. Well, the equipment that I would need is a FRA, like the Bode100 from Omnicron. And then you're also going to need a line injector like the Picotest J2121A. Okay, you need both of these to measure. By the way, you can use these to also measure the input impedance, but in this case we're going to measure the negative resistance. Okay. Okay, so I'm going to talk a little bit about the J2121, how it works. In my case, I'm going to have an input voltage fed on the right side. In my case, I'm going to put 12 volts input. Now this injector you can put up to 400 volts and 20 amps, but in my case it's just 12 volts. That 12 volts goes and is routed through, let me see where sorry, there it is. Okay, it's routed, the 12 volts is routed through, and it comes out through the left side or the right side, and you would connect it to your power supply. In my case, I'm going to connect it to my flyback. Okay, and then that 12 volts actually has a AC signal, and that comes from this source. This will go to the Bode 100, and it goes to the output of the generator. Okay, so basically the generator is going to output a little signal which is going to modulate the 12 volts. The signal goes into this amplifier, I believe, and it's going to modulate this 12 volts. Okay, now to make a measurement we need a voltage and a current. So we'll connect channel 1, or actually channel 2, to measure voltage. At the input of the power supply. Okay, and we also need a current source. That current signal is internal to the J2121A. That signal comes out through this BNC. This will go to channel 1. And that will measure the current. So V over I will give you R. Okay. So here is a simplified schematic of my power supply. What's unusual is that I'm not using an auxiliary winding to take over and power the PWM. Instead, I left it connected to the input voltage, which is 12 volts. Okay, so I have to modify the circuit a little bit, but basically you have the PWM here. Got the input filter, and we got the flyback here, or the converter. And basically I want to measure later on, eventually I want to measure the impedance there. But in this case, I'm interested in this impedance for now. This is the RN. I'm sorry. Okay, here we're going to do a measurement of the input impedance, but in this case we're going to do it without the input filter. So basically we're going to measure the impedance of the converter itself without the input filter. First of all, if we disconnect the hot side input of the primary of the flyback, we don't get any power. So in this case, I lifted the pin, okay, and I connected it to the 12 volts coming in from the J2121A injector. Okay, so the injector is injecting a signal from the Bode100. It modulates the 12 volts, and then it measures the current, and that current is routed to channel 1. Okay, so then that input voltage is coming in to the flyback here, and I'm going to monitor the input voltage with this probe, the PML 1110. It's a 10 times 10x probe, and that's going to go to your channel 2. Okay, so there is where is a little bit different. If I disconnect this 12 volts here, my PWM doesn't work, so I have to put a second supply. Okay, I'm connecting it to the input so I can power my PWM. Okay, so I have two supplies, but the one that I want to measure is this one, because this is the input of the flyback. Okay, so that's how you configure it. So now we go to and take a measurement. Start the measurement here. And we'll go ahead and do a sweep from 10 hertz to 40 megahertz, and we'll do a 30 or 300 hertz filter, and we'll increase this to 30 dB attenuation, and we'll press continuous. And here is the impedance. Okay, so the blue plot is the phase, so get rid of that because I'm interested in the magnitude. So this is the impedance. If you notice, this is magnitude and the units is in ohms. So you started around maybe 20, 30, 40 ohms, goes up to 60 and so forth, and it increases a little bit, but this is the input impedance. Okay, so now I don't think anybody has measured the negative resistance. At least I haven't seen any videos on YouTube. I may be wrong, and if I am, please let me know. But I think this may be the first time anyone has done it and posted it on YouTube. So let's see. And the one that told me about this was Pico Test. Steve Sandler said that you could measure it. So let's see if it's true. We'll do the, let's see, real. That's what we want, real. And hold and behold, he's absolutely right. If you notice here, the measurement where the control is still active, if you notice, it's a negative. That is very, this is the first time I've seen a negative plot, other than on my simulator. But this is kind of neat to see that you do have negative resistance. Okay, so let's expand that, and it's around 50-ish, 60-ish ohms during the bandwidth of the control loop. Okay, and then once the control loop can't control it, then it goes to the positive. But this is neat to be able to see this. I mean, this is, like I said, this is the first time I ever done this type of measurement, and I think it's pretty eye-opening that the concept of negative resistance is something really real. That's an actual physical. Okay, the measured negative resistance is very close to what I calculated. So that's the way you measure the negative resistance. Thank you for watching.